Geometry geniuses, what's up? Chapter 4, let's do this. This whole section is going to talk about how we can compare and contrast figures and polygons to see if they are congruent. Recall, congruency implies that segments have the same length or angles are the same measurement. Sometimes we'll denote that angles, again, are congruent if we see the same figure or the same pattern in the angle. Sometimes we can denote figures like segments, like AB being congruent to CD. So we showed this already with segments, but now we'll see how we can classify a figure as being congruent or a polygon as being congruent. So the first opening teaser here has you looking at a puzzle with 3 puzzle pieces that haven't been fulfilled into a spot. So based off of this, pause it, try to see what goes where compared to the size, shape, and location. You should be able to say that piece 1 probably fits into A, even though we would have to rotate it and kind of put it in there. We would also be able to say that piece 2 could go into B, and point 3 goes into C, which opens up the idea that although these aren't in the same configuration, they are still going to fit into this spot, or they should at least. With congruent figures, we're able to say that figures are congruent if and only if the shape, lengths, and angles are the same, or congruent. So with this section, we're pretty hands-on looking at a lot of shapes and saying, oh, these lengths are congruent, these angles aren't congruent, and then going from there to classify the figure collectively as being congruent. So we'll be determining 2 figures as being congruent based off of their corresponding parts, again, based off of lengths and angles. So let's get down to it. With the example seen here, we're allowed to say that the polygon ABCD is congruent to EFGH, because each segment from ABCD is congruent to some unique segment in polygon EFGH. We also see that each angle from ABCD has a corresponding angle in EFGH. So we'll see how we can do this with some examples. They're claiming that ABC triangle is congruent to XYZ. We are labeling the vertices of X, Y, and Z. So specifically, what can we say? What sides are congruent? What angles are congruent? Well, I know that they are saying that A to B is congruent with this segment over here. So we know AB is congruent to some other segment here, which is fine, but we don't necessarily know where. But this is actually going to help us. So we know that A was in this bottom left part of the triangle. We can imply that it's going to be this bottom right part of the triangle. So we can label this as X. We can continue to label this as Y. We can also continue to say that Z would have to be the missing one. So we know here that AB is congruent to XY. Also that YZ would have to be congruent to BC. And finally, for the sides, we can say that AC is congruent to XZ. And so far, we've done half the work, but now we need to see which angles are congruent. So we can hopefully see that YZX appears to be congruent to C. So we could say kind of the jumping ahead, and I think actually in this case we can just use the one letter. Yeah, so we can say that angle Z is congruent to angle C. We can also say that angle B, what's angle B going to be congruent to over here? Hopefully you're saying Y. So we can say angle Y is congruent to angle B. And in addition, left over, angle X is congruent to angle A. And so based off of this, we've labeled the triangle. We're allowed to say that these are congruent. And again, this is showing that the sides have congruent counterparts, and so do the angles. In this example, we have to draw the triangle, so we can do this pretty quickly. Just draw two. Try to draw them to scale. We'll go around the way on this. So FOX, congruent to CAT. The congruent congruent corresponding parts. Let's see. We could say that CA is going to have to be congruent to FO. OX is congruent to A to T. And also XF is congruent to TC. With angles, I'll just go ahead and mark this up. So angle F is congruent to angle C. Angle A is congruent to angle O. Angle X is congruent to angle T. There you go. So we see that based off of this, the side lengths from triangle Fox have a corresponding side segment or corresponding segment on the other triangle cat where they're congruent. We also see the same thing with angles. I hope this was helpful. We'll see in class that we take this further with some examples with algebra involved. Take care.